Hey folks, this is your Daily Dose of Duds on April 9th. Should be watching this lesson on. Alright, here's what we got going today. If you haven't watched video 10.8a, I need you to pause and do it right now. This is a tough target. We're going to spend 3 days working on this one, so everybody's going to do some practice on this quite a bit to get this one right. So go ahead and pause and take care of that. Alright, if you're still with me, I assume you've already completed that. Don't upload that picture yet. I'll have you upload it along with some other work here. Alright, here's what we got going today. You're going to have a choice of reviews here or doing a G67 activity. And then we're going to do some kind of introducing to the lesson, and there'll be a 4-blocker and some U-try problems. I'll want those all uploaded with one picture on this piece of paper here. So not a lot to do, but a lot to go over. We'll be practicing more the next 2 days. Let's get going with the review. If you're a G67 or an E67 kid, I'm going to have you do this right here. This is a Schoology activity. I'd like you to go ahead and complete that. You'll find one just like it on Schoology for the April 9th review. So you don't necessarily need to see all this. I know my lines are a little bit low there, but go ahead and you can work on that. If you are not a G or an E kid, then you can go ahead and work on this. Let me move myself out of the way here. And you can go ahead and pause for about 5 minutes and work on these problems. All right, let's run through the review. Get back over here into the corner. All right, finding the missing angle here. Well, if this is a 30 and this is a 60, that's 90 degrees. That means that this here is going to be a 90-degree angle also. So this is a scalene right triangle. 3 different angles, 3 different length sides. Identifying all the angles here, we've got a couple of different sets of parallel lines intersecting here. So if this is 105 degrees, A is going to have to be 105 degrees. The supplement to that will be 75 degrees plus, because A plus this number will have to be 180. So if this angle here, this acute angle, is 75 degrees, then B will be 75 degrees too. C is going to be 105, that's the obtuse, and the complement down here where my cursor is at, that would be 75 degrees. Find the complementary angle here. Well, it looks like you're going to need 15 degrees to make 90. That would be the complement and the supplement. If you laid that out there, you would need, whoop, there go the lights in my room here at school. You will need 95 degrees as your supplement angle. Find the missing angle here. Well, this is a quadrilateral. 1, 2, 3, 4 sides. So 360 minus 90 minus 90 minus 45 will give us 135 degrees for that angle right there. And then find all the missing angles. Well, if A is 40, B is going, if this angle is 40, B is also going to be 40, and A is going to be 140. Together, these two will make 180, so C is 140 as well. All right. Let's get rolling here. Let's play a little yes poly, no poly. You don't have to write this down. Let's just determine whether these are polygons or not. Is this a polygon, yes or no? Yes. Yes, poly. Good. It's got one area. It's got straight lines, no curves. Looks good. One area. Yes, poly, no poly. That's a no poly. That's a circle. How about this one? Yes, poly, no poly. Yes, poly. Straight lines, one area. Looks great. Closed shape. How about number 4? Yes, poly or no poly? That is not a polygon. That's no poly. This is an open area. It's not closed. How about number 5? Yes, this is a polygon. One area, straight lines, closed shape. Number 6. Yes, poly. This is a polygon. It's concave. It's pushed in here, but this is a polygon. It's got one area, straight lines, closed shape. Number 7. Yes, poly. How about 8? Yes, poly. And 9. No poly. This is not a polygon. It's got dangling lines here, so that is not going to be one. Let's just take a quick peek here. In review, a polygon, simple closed figure formed by 3 or more straight lines. Simple figure does not have lines that cross each other. In other words, you only have one area. you have drawn a closed figure, your pencil ends up where it started. Polygons can be classified by the number of sides they have. I also wanted to go over what a regular polygon is. A regular polygon is a polygon that has sides that are congruent and angles that are congruent. So this is a regular pentagon. Notice that all the sides are the same and all the angles are the same. This is a regular hexagon, regular heptagon. Okay? These are not necessarily going to fit the definition of regular because not all of the angles will be the same, even though all of the sides may be the same. Okay? All right, determine whether each of these figures is a polygon. How about number 1? Yes or no? This is definitely a polygon. I don't know why it's got red lines on it, but how about number 2? Negative. 2 areas. This is not a polygon. Even though it has straight lines, you have 2 areas. All right, let's get to the target today. Target for today is being able to take a regular or other polygon and find out what the sum of the interior angles is. So I'm going to show you a couple of different ways. The first way is that you simply grab one vertice and you make as many triangles as you possibly can coming off from that without drawing over the line. Let me see if I can get this one to light up. There we go. I already did it for you. So if I trace this line here, I don't make a triangle. If I go to this vertice, I'm just drawing over the top of a line or tracing over it. But all these other ones all make triangles. And for every one of those triangles, there's 180 degrees. See if I can get this other one to go. Somewhere in here. There they are. So all of these are 180 degrees. So if you add all of those up, you have a total of, let me just get rid of this guy. You have 1, 2, 3, 4, 5, 6, 7, 8. You have a total of 8 triangles. Each have 180 degrees, and this is 144 degrees. Now this is a regular polygon. All the sides and the angles are all the same. Therefore, we can figure out what every angle is too. So you take that total sum of the interior angles, which is 1440 degrees. You divide it by 10. Just cross off the zeros. You have 144 degrees for each of these angles. All right, here's another one. Real simple rectangle. It still works. One vertice. Draw as many lines as you can to divide up into triangles. I can make 2 triangles. They're each worth 180 degrees apiece. So that's a total of 360 degrees. This is not a regular polygon because 2 sides are long and 2 sides are short, but it is a rectangle so that we can take the 360 degrees and we can divide it by 4 angles, and they're all 90-degree angles. Okay? All right. Let's keep moving. Time to try one more. What is the sum of the interior angles in each of these shapes here, and what is the measure of each angle? Well, let's see if I drew this one. I guess I did. There it is. Can make 3 different triangles, so there's a total of 180 plus 180 plus 180 degrees. That's 540 degrees. Now this is a regular pentagon. All the sides and angles are the same, so if I take that 540 and divide it by 5, I'm going to get 108 degrees. Notice you divide it by the number of sides, not by this number here, which is the number of triangles. You divide it by the number of sides. So each of these angles here is 108 degrees. That makes sense. This is 108 degrees here. This angle here was 144 degrees. This is more obtuse than this angle here. All right, so what if you were to get one with like 150 sides on it? Would you still have to draw those triangles? Well, you could, but I'd hate to have to draw the shape and rely on the math. You can also use this formula that's right off the MCA test for 6th grade. It says that the sum of the angles is equal to 180 degrees times the number of sides minus 2. All right? So I know that's kind of complicated, but let's look at it. Here's the sum of the angles. We take 180, we multiply it by the number of sides that are on the shape, and we just subtract 2 from that. So let's just try that on this hexagon here. So the sum is going to be equal to 180 degrees times the number of sides, which is 6, 1, 2, 3, 4, 5, 6, minus 2. Simplify. That's really 182 times 180 degrees times 4, which is 720 degrees. Now, if it's a regular hexagon, and this is a regular polygon, a regular hexagon, all the sides and angles are the same, you can divide that by the number of sides it has, which is 6, and find out that each angle is 120 degrees. There we go. Each of these are 120. All right. I've got 4 you-try problems, and I'd like you to take and put these right down here in the you-try section. Let's go ahead and have you try this first one here. Find the value of x in the diagram shown. Okay. Notice I took and rewrote this. I switched it up a little bit to make it a little bit easier to use. All right, let's see how you did. Well, this is not a regular one. We can tell that because all the sides and angles aren't the same. But I can still take the 6 sides and subtract 2, which is 4. And I can multiply that times 180, and I'm going to get 720. Okay? And insert one step here that I kind of skipped over, I guess. 4 times 180 equals the 720 degrees. Now, we still have to find what this guy is here. Well, if it's not a regular polygon, or a regular hexagon in this case, then we need to take and subtract out all the other angles to find out what the missing angle is. So, here's the way I've done that. Just move these guys down just a touch. Well, the first thing I did was I knew that there were 720 degrees in the whole thing, because that's what I figured out. And then I just subtracted. Minus 88, minus 142, minus 105, minus 136, minus 136. And I got a total of 113 degrees. X is going to be 113 degrees. Now, another way to do that is you could just take and add all of these guys up, add all of these angles up, and you're going to get a total of 607 degrees. Plus this angle here would equal 720 degrees. So you could do a little equation there where you subtract 607 from both sides and you'll get x equals 113 degrees. I think either way is fine. I do this way here. I make it into an equation if it's getting a little more complicated. Sometimes if there's decimals and things like that involved, they're fractions. Other than that, I just pretty much subtract from the total. All right, so have you try number 2. All right, the diagram shows a hexagon. What is the size of angle x, or what is the measure of angle x? Go ahead and take a minute. All right, let's see how you did. Well, I use that formula, the number of sides minus 2 times 180, to determine what's the sum of the interior angles. So there's 6 sides again, 1, 2, 3, 4, 5, 6. I subtracted 2, and I multiplied that by 180. There's my 4 times the 180. So I got 720 again. So I just subtracted out all of those other ones. 720 minus the 90, minus the 110, minus the 130, minus the 160, minus the 120, and had 110 degrees left, so B was the correct answer. Notice how I went in order clockwise, and I started right up at 12 o'clock or at noon. I always do it the same way so I don't count one angle twice. All right, let's keep moving. You try number 3. Go ahead. What is the size of one interior angle on a nonagon, a 9-sided polygon? This is a regular nonagon, so all sides and angles are the same. See if you can figure it out. Okay, let's see how you did. Well, the number of sides minus 2 times 180 will give me the total sum of the angles. So 9 minus 2 is going to be 7. Just move this all over. 7 times 180 is 1260, so I just have to take that 1260 degrees that were total and divide it by 9, and I would have 140 degrees. Okay, and one more for you. And then we'll do your 4-blocker. You try number 4. What is the size of one interior angle of a regular 20-sided polygon? Now this isn't one you're going to want to draw. So go ahead, figure it out mathematically. Pause the video. Okay, let's take a look. Well, again, we use the formula, the number of sides minus 2 times 180. Well, 20 minus 2 is going to be 18 times 180 is 3,240 degrees. So I have to take that, and I have to divide that, not by 18, but by 20, because there are 20 sides in that. That gives me 162 degrees. All right, lovely. All right, now you're going to be moving to a different spot on your, down here in the bottom right-hand corner. I'd like you to put a little 4-blocker. and answer these 4 questions. Find the value of x in this first one here. Find the value of x in number 2. Ooh, tricky. Find the value of x right here. That's going to be the supplement to this interior angle. And then what is the measure of one interior angle of a 10-sided regular polygon? Go ahead and take your time. Okay, let's see how those answers come out. Well, this first one, it's a pentagon, so 5 minus 2 would give me 3 times 180. It's going to be 540. Sorry about that. Got a total of 540 degrees, and then you can just subtract them out. 540 minus 120 minus 105 minus 115 minus 105 again. 95 degrees. And that looks like a 95. You know, here would be 90. So x looks like to me it's 95 degrees. Right here, this here again is a hexagon, so 6 minus 2 is 180. You got 4 times 180 is 720 degrees. And we divide that by the number of sides. And we've got 120 degrees per side. This next one's a little tricky. Probably have to move myself over here. All right. So 8 minus 2, it's an octagon. 8 minus 2 is 180. Or 8 minus 2 is 6 times 180 gives me 1,080 degrees. So if I take this 1,080 degrees here and I divide that by 8, I'm going to find out that this angle right inside here where my cursor is 135 degrees. So now I have to take and subtract that because I don't want that angle. I don't want the 130 degrees right here. I want this exterior angle, which is going to be an acute angle. So I'm going to take the 180 degrees, which would be the entire straight line. I'll subtract this 135 degrees, and I've got 45. This is a 45 degree angle right out here. Okay? That supplement complement stuff is coming in handy. Okay, last question. What is the measure of one interior angle on a 10-sided polygon? 10 minus 2 is 8. Times 180 is 1440. We take that 1440 and we divide it by 10. We're at 144 degrees. All right, folks. I'm not going to kid you. This is a tough target. You are done for the day. I've got some optional practice here. Right now, before I sign off, make sure that you've uploaded the U-Try problems, the 4-blocker, and either the pink review or the G67. If you're a G67 or E67 kid, you don't have anything to upload here. This was just a Schoology activity, so you wouldn't have to do that. I already have your grade. But upload that side by side along with your video ticket to the video 10.8a, and I'll check that and get your points on that. All right, let's go back. If you want to hang around for some additional practice, here are some other problems. I'm just going to show you 6 of them. I guess I'm going to show you 5. Find the sum of the interior angles, and then each interior angle, these are all regular polygons. Okay, I'll even give you some more to take a look at. I'll slide this over, so if you want to do 12 instead of just 10, there's a 12th one. Okay, and here are your answers to those if you did those problems. Okay, all right, thanks for practicing. We will see you tomorrow.